Welcome to Spring LIB.
Okay, so this is a reaction about the stoichiometry. So the reaction is ammonia reacts with hydrogen chloride to form a solid, which is ammonium chloride. And we can see the mole ratio is 1:1. So it gives us that both of them have 5 grams. So the first thing is actually calculate the moles of the two reactants. So the mole of the initial ammonium actually equals to the mass over the mole mass of the ammonium, which is 5 grams over ammonia is 17 grams per mole, which is around 5 over 17 is actually around 0.294 more. And the moles of the hydrogen chloride, the mass over the mole mass of the hydrogen chloride is 5 grams over 36.5 grams per mole. And this is actually equals to around 0.136137 actually. So now you can clearly see in the original reaction, the moles of the hydrogen chloride is less than the ammonium. So definitely the hydrogen chloride will be consumed since the reaction ratio, mole ratio is 1:1, right? So the first answer, A, for A, is actually HCl will be consumed. And what would be left is ammonia will be left after the reaction is complete. So the ammonium will be in the flask. And the question B is what would be the final pressure of the system after the reaction? So the pressure is depending on the moles of the molecule. So we then need to know after the reaction, what is the moles of the ammonia? So it's actually simple because this reaction is 1:1 ratio. What we need to do is we know that actually the mole of the consumed hydrochloride will actually equals to the moles of the ammonia that is consumed. So what we need to do is just use the original moles of the ammonia minus original moles of the hydrogen chloride. And this actually equals to around 0.157 more. And once you know that, we can just use simply ideal gas law, PV equals to nRT. And we want to know the pressure. The pressure just equals to nRT over the volume. So here the N is 1.57, R is 8.314, and T is 25 degrees C, but we need to change into the Kelvin, which is around 300 Kelvin. And over the volume, here it used 2 liters, but the unit has to be meter cubes, so it's 2 liter equals to 2 times 10 to minus 3 meter cube. And we just need to do the calculations here. So it's actually around 194.685 kilopar. And this is the answer. And then it said what's the mass of the ammonium chloride will be formed. Let's see. So first we need to know how many moles of the ammonium chloride. So since this reaction, right, 1:1:1, the reactant product ratio is also 1:1. So we know that the moles of the produced the ammonium chloride were actually simply equals to the moles of the hydrogen chloride that was consumed, which is 0.137 mole. And the mass of the ammonium chloride, which simply equals to the moles of the ammonium chloride times the mole mass of the ammonium chloride, which is 0.137 times 53.5, and this is equal to around 7.3295 grams. And this is the answer.